this is a nice starter, and I'm again amazed at how many times people get this wrong. We have to define gravitational field strength and then give the SI unit for gravitational field strength. Actually, gravitational field strength is one of the equations which is given for you and already defined for you. This equation here, tiny as it is the definition of gravitational field strength. It is the force per unit mass at that point in the field. So you might want to add the word gravitational there. Okay, gravitational force per unit mass at that point in the field. If you're not feeling sure, write down the equation because it will help you with the next bit. Okay, now SI unit, well, G is equal to F over M. The units of G are going to be the units of F divided by units of M, which is newtons per kilogram. All right, not Newton kilograms, newtons per kilogram. Really important we get that. This is a freebie of a mark which I've seen students lose, and it's just basically through, perhaps people think it's a bit too easy. We're then asked to do a little bit of work with our stuff. This is the meat of the question, or look at this, okay? We've got a planet orbiting the sun in a circular orbit with period t and orbital radius r, mass of the sun is m. We're going to ask this. Now, I've had a little look at this, and I think that even though in IB you are given this equation, I really would suggest that you stay away from it, okay? Because the approach that they want, as with other exam boards, as with A-level, okay, is as follows. When you are doing any derivations of anything, for example, that t is equal to square root of this, start with a force balance, okay? In other words, that the gravitational force provides the centripetal force. Why? Well, that will then allow you a really nice basis to go through and do the working out. Now, in this case, what we're going to do is we're going to try and calculate t, okay, and we're going to use the fact that there's some cancellations, etc., that we can do here. If we start off with our Newton's law of gravity, G m, big M, small m, divided by r squared, is equal to my centripetal force, m omega squared r, okay? There's another version of this, which could be m v squared over r. You could use that as well. It just requires a little bit more work, okay? You're going to cancel your m's, and you're going to bring your r up to the top here. So we've got a nice relationship here, which is gm equal to omega squared r cubed. Why is that important? Well, we know that omega is 2 pi over t, so omega squared is 4 pi squared over t squared. You can see here we're getting to the shape that we want with a t. Now we're going to bring t up, okay, and we're going to bring gm down, and then we're just going to square root the whole thing, and that will give me my Kepler's law, okay? All right, now as I've said, I noticed a few times when students do this question, they start with that equation for A, and I can see why they do it. And just in the answers and the mark schemes for these kind of questions, IB tends to want you to start with a force balance, and so you should by all means do that. Okay, now regardless of how you got on in question I, all right, you can do question II, all right, because you're told the radius and you're asked to estimate the mass of the sun. A little bit of thinking will remind us that the Earth takes 365 days and 24 hours, 60 and 60, 3.153 times 10 to the 7 seconds to go around the sun. So therefore we know T, we know R, we know G because it's a gravitational constant. And again, it's in your data booklet, G equals 6.67 times 10 to the minus 11. And all we're doing is plugging in those horrible numbers to get a value here, which is 2 times 10 to the 30. Now this is the current estimate for the mass of the sun, so I know that that is the correct value. I know I'm going to get marks here. It's worth being familiar with these answers, these values, sorry, because it then helps you with your answers on these kind of proven questions. All right, I hope that's clear. Big message I want to put out there is that even if you can't do the first bit, you can do the second bit with a little bit more thinking. So don't give up. If you're doing physics questions are not necessarily linear, you can jump around a little bit and make sure that that you're able to answer at least a part of the question, even if it's the second.